Let's simulate the coding for this problem. We are just given the intended direction and we are giving the number of steps. So we need just to simulate them, but in a smart way. And to do that, all what we need is to consider the something like the our position neighbors. Anyway, we started by reading the input and splitting it. And as you know, the number of commands weren't given for us. So to do that, one way, I'm reading the number of rows and columns and taking an asterisk commands of the remaining. Remember, asterisk commands mean get whatever varying arguments here. For example, if we give 10 values, row and column will have 10, and commands will be a list of 8 values. After that, I'm converting the rows and columns. The robot has 4 choices: up, right, down, and left. So I created here a couple of matrices, couple of lists to express the change that might happen to one of these 4 directions. After that, we as long as the commands aren't empty list, the first thing is we extract one command, which is a direction and the number of steps. And again, I am updating the commands with the remaining of the commands. For example, if the commands initially were 8, then we take these 2 guys here, then now the commands will be 0. The first thing is I would like to know the string, which one of these guys. So one easy way is I created a list of the 4 items, and then by calling the index over this object and the direction, then it's going to match the up to 0, right to 1, down to left, and so on. So definitely this list order should match this one order. Okay, this is an important step. After that, we have the number of steps, and the change here is if we are at position R and position C, and we would like to move one step to the, let's say, to the up, then we move one step to the up. But what if I would like to move like 10 steps? Then again, in the same direction, I just can multiply with 10 to move 10 steps. 1 million step. Then again, you can multiply with 1 million step to move in the grid. Now, what about the circulating issue? The circulating issue can be directly solved by the modulus operator, because the modulus will get rid of any kind of like unnecessary cycles like we learned in the clock. Every 12 hours are useless. So now we are in a matrix, and every, let's say, every n rows iterating in the rows direction are just useless. The robot is coming back to the same location exactly. So the modulus here is helping us removing the unnecessary values, and as a result, we don't care how big is the modulus value. That's all.